the universal set, we do a little horseshoe like this, equals, and then we do squiggly brackets. So whenever we're listing what the elements are, we put them in a set. We put them in the squiggly brackets, okay? So the only numbers I can use are 0 to 9, and I'm listing those numbers. I put them in squiggly brackets. I say this is the set U. U's are it's capitalized, so it's the set. And then the numbers I put in it are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And now for the rest of this question, no matter what it asks for, those are the only numbers I'm allowed to use. So I could use all of them, I could use none of them, I could use some of them, but I can't use anything outside of those because that's the universal set for this question. So here it says, she defined the following sets. E are the even numbers. Now people are like, well, -3 or -4 is even, and 12 is even, and 16 is even. That's lovely, but are those part of the universal set? No, so I can't list those, okay? So E is going to be the numbers, the set of which of these are even? 0, what? 2, 4, 6, 8, and then I have to stop, right? So let's write that down. Remember, you have those chapter tests where you're allowed your notes. You aren't allowed anyone else's notes, so make sure you do your notes well. Because a lot of people come to the test and then they want to like look and try and figure something out, but their notes are completely blank, and that's what you get. Okay? Now this next one says L represents the whole numbers less than 7. What do the whole numbers start at? The number with a whole. Where do they start at? 0, right? And then 1, 2, 3, 4. So whole numbers less than 7 out of this universal set include 0, 1, 2, 3, 4, 5, 6. Do I include 7? I would include 7 if it said less than or equal to, but it doesn't say that, so I don't include the 7. Okay. The next one says odd numbers less than 7. So what am I going to start at? 1. So I'm going to have 1, 3, 5. Do I include 7? No, because it says less than it, right? So we list them in the space above, and we'll use these to make the definitions below make sense. Okay? So the universal set is some big set that we're allowed to choose from. It might be the natural number system. It might be the whole number system. It could be integers, right? It can be anything that they state, but they have to state what the universal set is that we're allowed to choose from. Then we talk about subsets. Can everyone put their pencils down? Because subsets are really easy to understand if we're paying attention, but brand new, so kind of weird if we don't. So a subset means that everything in one set is contained in the other one. So for example, if my first set contained 1 and 2, my next set, to make this be a subset of this set has to contain at least 1 and 2. It could contain 5, smiley face, piggy. It doesn't really matter what else it contains, but at minimum, if this set is a subset of this one has to contain whatever this one has. So if this one had 1, 9, and 4, this one would have to have 1, 9, and 4, but it could have 10, 17, -5, whatever. Yep?
Does it have to be in the exact same order?
No. Just has to have the same elements. We always try and write them for, teachers would make their hearts sing if you write the numbers in order from low to high, but if you wrote them out of order, I can't take off marks. Unless they said in ascending order or something like that, which they never do. But if you write them in ascending order, you won't miss a number. Sometimes happens. But if you write them out of order, I can't take off a mark. All right. So let's look at this. This one says, you can pick your pencils back up. A subset of a set is a set that contains, and it's going to sound super overwhelming, is a set that contains some or all or possibly none of the elements from a previously defined set. All sets we deal with in a problem must be subsets of the universal set, and every set is a subset of itself. Subsets are represented by this symbol, this like kind of sideways U. And it's shown here. Like if you look in your, remember this is your formula sheet. I'm going to give you guys one on Monday. They're bright orange. You can have them in plastic sleeve. This represents subset. It tells you that. But if you don't know what the definition of a subset is, it doesn't matter that they tell you that's a subset. You wouldn't be able to do the question, right? But it is on your formula sheet. It's a sideways U. So it looks like this, or a long C. In set notation, the symbol that is used to represent the relationship between sets. So for example, set E is a subset of set U, U being that universal set, right? Which means all the elements in E are found in U. So they're going to show it this way. Set E is a subset of U. Well, let's talk about it. If we say E is a subset of U, well, let's look at E first and see if all of its elements are in U. So E has 0, 2, 4, 6, 8. Would you agree? We stated above. So U has to have at least that, right? Can it have more? Yes. Can it have missing one of these? No. It has to have at least those, and then it could have more, right? So 0, U has 0. 2, U has 2. 4, U has 4. 6, U has 6. 8, U has 8. So E is a subset of U. That is true, right? Does that kind of make sense? Everything in E, the first letter, first set, has to be found in the second set in order for this to be a subset of this. So for example, this class is a subset of the school population, right? Everyone in this class is found in the school population. Is the school population a subset of this class? Is everyone in the school population found in this room? No. So just because you're a subset one way doesn't mean it's a subset the other way. Like for example, the universal set is not a subset of E because there's way more in the universal set than there is in E. Is E a subset of itself? Is E a subset of E? Is everything in E in E? Yes. So every set is a subset of itself. And the empty set, which looks like this, is a subset of every set. It's empty. It contains nothing. So it'll work in all of them. That's a really stupid one, but it comes up sometimes. So let's look at this bullet. It says, is set E a subset of set L? So sometimes they use the word subset. Sometimes they use the symbol subset. Okay? So they could ask, is E a subset of L? Or we could say E a subset of L question mark. Right? They mean the same thing. You can use words or you can use symbols. So in order for E to be a subset of L, everything in E must be an L. Okay? If at any point in time one of them doesn't work, it's done. It's not a subset. So let's look up here. Is E a subset of L? Okay. E has 0, L has 0. E has 2, L has 2, E has 4, L has 4, E has 6, L has 6, E has 8, L doesn't have 8. So is E a subset of L? Is everything in E in L? No. So we're going to say no. And how we can represent that is we can say E is not a subset of L. Make sense? All right. The next bullet says set O is a subset of L, which is a subset of U. Let's see if that's true. O is a subset of L, is a subset of the universal set. In order for that to be true, everything in O has to be in L, and everything in L has to be in U. Yeah? So let's see if it's true. It says it's true, but let's actually prove it. So O is a subset of L. So that means everything in O has to be in L. So O has 1, L has 1, O has 3, L has 3, O has 5, L has 5. So O is a subset of L. True statement? Now we have to see, is L a subset of the universal set? So L has to be contained in U, which it should be because we took it from the universal set, right? But let's check. L has 0, U has 0, L has 1, U has 1, L has 2, U has 2, L has 3, U has 3, L has 4, U has 4, L has 5, U has 5, L has 6, U has 6. So, O is a subset of L is a subset of U is true. Yeah? Subset makes sense? Everything in the first one has to be contained in the next one. And if not everything, even if one thing isn't, it's done. It's not a subset. Just like that 8. Okay, like I said, the first 2 days are heavy definitionally, and then the rest of the year really isn't. So it's not all like this. The empty set. The empty set is a set that contains no elements. It's empty. That makes sense. Empty set has nothing in it. It's empty, right? It's denoted with this 0 with a line through it. So if you look here, it shows it here too. 0 with a line through it is the empty set. How's that? For example, the set of all odd numbers in set E is 0. There are no odd numbers in E. Okay? We'll talk about the empty set more in a little bit. Complement of a set. The complement is denoted with this little apostrophe. A complement, it shows it here. It could be B complement, E complement, L complement, right? You just have to have that little apostrophe. So here it says, the complement of set A in the set is the set of all elements in the universal set that are not in A. Okay? So the complement of set A is denoted like this on the formula sheet. We don't have any sets A's in this example, but we do have E's. So here it says, write the complement of set E using proper notation. So we're going to go the complement of E. So if we wanted the complement of this math class in the student population, it would be everyone not in here, correct? And the universal set would be the student population. So the complement of this class is everyone not in this class, but in the school. We agree? So you have to have some bigger universal set that you have that is not, so that you can say what's not contained in that set. So for example, what's not in E? Well, in order to state what's not in E, let's state what is in E. E has, you have it above, you don't have to state it. Mine's just really high, so I'm going to rewrite it. 0, 2, 4, 6, 8. 0, 2, 4, 6, 8. And then we have some big universal set. Universal set is the single digits. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what we have to do is we have to state what's not in E, correct? What is in E? 0, 2, 4, 6, 8. So we're not going to state those. We're stating what's in the universal set, but not in E. That's the complement of it. Okay? So E has 0. Well, we're not going to write that. So what is not contained in E, but is in the universal set? 1, the number 1. 2 is in E. 3. 4 is in E. 5. 6 is in E. 7. 8 is in E. 9. Do we agree? It's just what not's in. So you need to have a universal set in order to give a complement. Because you need to know what the big set was in order to state what's not in that value, right? Okay, let's flip over to example 2. Consider the following 2 sets. So A is the natural numbers less than 20 that are divisible by 3. Natural numbers less than 20 that are divisible by 3. And B is the natural numbers less than 20 that are divisible by 5. Explain why the set of natural numbers less than 20 is a suitable universal set. Universal set's the only numbers we're allowed to look at. Why would that be a suitable universal set for A and B? What are the limitations on A and B? You're only allowed to use what? The natural, what does it say? Natural numbers less than 20. Both of them states that, correct? So the universal set being the natural numbers less than 20 works because that's all I'm allowed to use for both of them. So the universal set be the natural numbers less than 20. Since both sets are limited to that. If ever I'm given a universal set, I will always write what it is in set notation with all the numbers because it helps you. Because if you're ever asked for a complement, it's a lot harder to find a complement if you don't know what the universal set is. So we're using definitions from yesterday. Natural numbers. What do the natural numbers start with? Remember, natural numbers are the natural numbers you count as a toddler. What do we start with? 1. And we want less than 20. So what are we going to stop at? 19. So let's go. So the universal set is like that little horseshoe. It equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Now some people say, I don't need to write out the universal set because then I got this, I can do it in my head. The moment you do anything in your head and you don't write it down, there's a larger chance of an oopsie. The only reason not to write these numbers out is because you literally don't want to use your pencil and move your hand. That is the only reason why you would not write these out. Okay? So, A is the natural numbers less than 20 that are divisible by 3. We talked about divisible yesterday. When we divide by that number, we don't end up with decimals, right? That's what divisible by 3 means. Yeah? So anything that's divisible by 3, if I divide it by 3, I would get a number that works, like a natural number. So of the numbers 1 to 19, which of those, because that's my universal set, that's all I'm allowed to choose from, which of those are divisible by 3? If I do 1 divided by 3, I get 0.333, like that doesn't work. 2 divided by 3 doesn't work. 3 divided by 3, 1. So that's my first one. What would be my next one? 6 and then 9, yeah. Then 12 and 15 and 18. So multiples of divisible by actually end up working out to the same numbers, right? If I said multiples of 3, will result in the same thing. Okay, then we're going to go to number 2, which is B. B are the natural numbers less than 20, so I use 1 to 19, that are divisible by 5. 5, 10, 15. Exactly. What does this mean? A with the little thing. Complement. So the complement of A. So that's a fancy way of saying not an A, but in the universal set. Correct? A contains 3, 6, 9, 12, 15, 18, so I can't count those. But everything else from 1 to 19 is in. That's what the complement is, right? So I'm going to get 1 and 2, not 3, 4 and 5, not 6, 7 and 8, not 9, 10 and 11, not 12, 13 and 14, not 15, 16 and 17, not 18, and then I stop at 19 because that's what the universal set stops at. I'm not allowed to keep going, right? Then here it says, write a description, so words, of the elements of the complement of set B, so in words. So B says natural numbers less than 20 that are divisible by 5. What would the complement be? The natural numbers less than 20 that are, what would be the opposite of divisible by 5? That are not divisible by 5. That's it. So the complement, if B is the natural numbers less than 20 that are divisible by 5, the complement would be the natural numbers less than 20 that are not divisible by. Yeah? So it's just the complete opposite. Basically, complements are opposites. So a lot of people will tell me that prime numbers and composite numbers are complements. But prime numbers and composite numbers are not complements because one is neither prime nor composite. It has to be complete opposites of each other, right? So odds and evens are complements because they're complete opposites. Okay, let's look at set C. Set C says natural numbers less than 20, so we're still using the same universal set, that are multiples of 6. So let's look at C. Multiples of 6. What are we going to start at? 6, then 12, then 18. What does this little symbol represent? Yeah, subset. So everything in C has to be in A, right? If it's a subset. So I want you guys to try this out. 1, 2, and 3. See how you do. It says state whether the following are true or false. So your answer can be true or false. All right. Is C a subset of A? Is C in A? Well, let's check. C is 6, A has 6, C has 12, A has 12, C has 18, A has 18. This is true. Conversely, answer me this. Is A subset of C? Is that true? A has too many elements. A has 6 elements, C has 3. That's physically not possible. You have to have at least the same amount of elements or less than this one, right? You can't contain them. So this is not true. Right. C is not a subset of B. So let's look at C. C is 6. So C has 6, B has... B already failed. So it failed, right? So C is not a subset of B is true. Now, a lot of people try and do that one. A lot of people... Stop it. A lot of people try and do... I don't know what I did. I'm old and I put on some notifications and now it's like buzzing. I need to slow down the notification roll. Like maybe I don't know what, toss it out of the window, or in my old age figure out how to turn those notifications back down. Because this watch be buzzing and it's gonna last like about 3 hours. And then you get hi. Hello. How are you? Good. How are you? I'm good. Okay. A complement is a subset of C complement. People try and do in their heads. I don't roll that way. So A complement are these. I would like writing out C complement personally myself and then counting. So it's 6, 12, and 18. So I'd have 1, 2, 3, 4, 5, not 6, 7, 8, 9, 10, 11, not 12, 13, 14, 15, 16, 17, not 18, 19. Okay. So this is A complement, that's C complement. A complement is 1, 1, 2, 2, 4, 4, 5, 5, 7, 7, 8, 8, 10, 10, 11, 11, 13, 13, 14, 14, 16, 16, 17, 17, 19, 19. Is that true or false? True. So a lot of people try and do it by like visualizing not C in their heads. I can't. So I'll take my not A, I'll take my not C. Not C is everything but 6, 12, and 18, and I will go 1 has 1, 2, 2, 4, 4, 5, 5, 7, 7, 8, 8, 10, 10, 11. You know what I mean? Not A, not C. Yeah. Okay, this is going to be your homework, but for I'm adjusting the letters because I don't like these letters and I forgot to adjust them. So the letters for that one are going to be G to L because the other ones are just confusing. So we're bypassing them. G to little l. I will post this page in Google Classroom as well. Go away, little box. Okay. But you'll have 1, 2, 3, 4, 5, and 7. You have plenty of time if you work that it would be done before you leave this building. You shouldn't have to go into Google Classroom to get sleep.